factors, multiples, HCF and LCM. That is what we're on to right now. Here. Alright. Factors, multiples. Let us see what a factor is. When we talk about factors, here now, a factor of a number can divide into the number without leaving a remainder. Let us look at an example. Factors of 100. We want to see some factors of 100. Now, if we say, alright, let's put them in brackets here, curly brackets, because it's a set of numbers, so we use curly brackets to represent a set. Suppose you say 100 divided by 1, you get 100, no remainder. So 1 is a factor of 100. 100 divided by 2 is what? 50, no remainder. So 2 is a factor of 100. 2 can divide into 100. You get the answer, but no remainder. I could write it like this as well. 100 over 2 is 50. Remainder is 0, no remainder. You see? Now, let's try 3. 100 divided by 3 is what? Is going to be 19. Oh no, 33. Remainder, if you multiply 33 by 3, you get 99. So 1 is left over. Remainder is 1. See that? 3 into 100 is 33. Remainder 1. You get a remainder. So 3 is not a factor of 100. Try 4. 100 divided by 4 is what? Let's say 4 into 4, 1. 4 into 10 is 2. Remainder 2. 4 into 20, 5. 4 into 100 is 25. No remainder. So therefore, 4 can divide into 100 without leaving a remainder. 4 is a factor of 100. What about 5? 100 divided by 5. I know that is 20. No remainder. So 5 can divide into 100 without leaving a remainder. So 5 is a factor of 100. Let's try 6. 100 over 6. That will be the same as 50 over 3. You see? Now, let's just direct with the 100 over 6. 6 into 6 is 1. 6 into 10 is 1 time. Leaving 4. 6 into 40. Well, 6, 6, 36. We have 6 sixes are in 40. How much is left over? Well, it's 4. Remainder 4. When you divide 100 by 6, you get your answer, yes, but you get a remainder of 4. So since you get a remainder, 6 is not a factor of 100. Now, if you try it with 7, you will get a remainder. Try it with 8, you get a remainder. Try it, divide 100 by 9, you will get a remainder. But we divide 100 by 10. The answer is 10, remainder 0. No remainder, therefore 10 into 100, you get your answer, no remainder. So 10 is a factor of 100. Next number in line is 20, because 100 divided by 20 is 5 flat. So nothing remaining. See that? So therefore 20 is a factor of 100. What could be the next one? Well, 25 divided by 100 is 4. No remainder. So 25 is a factor of 100. I know that the next number is 50. 50 divided directly into 100 because you get no remainder. Here is one more. What could that factor of 100 be? Well, people, a number is always a factor of itself, because if you try to divide 100 by 100, you get your answer 1. No remainder. So the next one is 100. So those are the factors of 100. They can divide into 100 without leaving any remainder. So that is a factor. Now, in all cases, you will find that 1 is a factor of every number, and the number is always a factor of itself. So every number has at least 2 factors, 1 and itself. Make a note of that. You see that? Good. So, those are factors. Then next in line, we have what we call multiples of numbers. Alright. Multiples. Multiples of the numbers now. Let us see what those are. Now, a while ago, we see that factor of the number can divide into the number. But we will now see that the multiples of the number are those the number can divide into. So you see, right, multiples we're going to talk about. Multiples of the number. A while ago we saw factors of 100. But right now we're going to look at multiples of 100. we have 100. And we're looking at multiples of 100. 100 can divide into itself without leaving a remainder. Now, that means multiples of 100 is 100 itself. In fact, we'll make a note that every number is always a multiple of itself. Every number that works with. You see that? Now, another multiple of 100. 100, 100. 100 can go into, let's not jump too far with the number. 200, meant to say. 100 can divide into 200 without leaving a remainder. In fact, it is 2. So, here, 200 is another multiple of 100. Suppose we try 201. Is it a multiple of 100? 100 into 201 is 2, remainder 1. You get a remainder. So, 201 is not a multiple of 100. Let us try 105 divided by 100. You get 1, remainder 5. Since you get a remainder, then 105 is not a multiple of 100. Let us try another number. 300 divided by 100. Is 300 a multiple of 100? When you divide 300 by 100, you get 3. No remainder. So 300 is a multiple of 100. You see. So multiples are those numbers, either the same number or bigger number, that the number can divide into without leaving a remainder. You see. Now, the fact is, no matter how much we move forward, there is no end to the number of multiples. So I will put 3 dots and before I close the brackets. Alright. Now, here, look at multiples. Now remember, based on what we saw a while ago, F, A, C, T, O, R, S, factors, and M, U, L, T, I, P, L, E, S, multiples. The factors of a number, either 1 or the number or smaller numbers. Factors of a number are always 1 and the number itself. But then you have smaller numbers that can divide into the number without leaving a remainder. As for the multiples, it's either the same number or larger. I should say and. Because with every whole number, you can always find a bigger number that I can divide into. So the number are larger. So generally, factors smaller, multiples larger. Factors smaller, multiples larger. Factors smaller, multiples larger. Alright. A few more examples. Factors of 15 would include 1. What else to say? Tell me. Next number. 3. Then 5. Then one more. 15. Because these can divide into 15 without leaving a remainder. So the factors would be under the line. It would be the denominators. So 15 over 1. Factor. 15 over 3. Factor under. 15 over 5. Factor under. 15 over 15. Factor under. You see, the factors are under the line doing the division. The smaller one are the same. Get that? Alright. Multiples of 15 now. What are they? Now, 15 is the first one. Next, 30 is the second one. Why? You can multiply 15 by 2 to get a factor. It's 30. So therefore you can say 30 divided by 15 to get 2. So therefore, no remainder. So there are 2 whole 15s into 30. You see that? Next one, 45. Why? Because 15 can divide into 45. You get your answer. No remainder. Next, 60. But remember, it goes on and on. There is no end to the number of factors. So you see that? So those are factors and multiples. Factors small, multiples bigger. Factors one number and smaller, multiples are the numbers and bigger numbers. Right. Now, people, that is going to be it for this video. We continue HCF and LCM in the next video.